problem that wants me to divide and simplify as well as state restrictions on the variables. So here I have 2 minus x over x squared plus 2x plus 1 being divided by x squared plus 3x minus 10 over x squared minus 1. So I have a fraction divided by a fraction. Let's recall that dividing by a fraction is the same thing as multiplying by its reciprocal. So the first thing I'm going to do here is I'm going to rewrite this division problem actually as a multiplication problem, and then it'll become a lot like the example we just did on a previous one where I showed you how to multiply and simplify. So this will become 2 minus x over x squared plus 2x plus 1 times x squared minus 1 now in the numerator, and x squared plus 3x minus 10 in the denominator. So again, dividing by a fraction is the same thing as multiplying by its reciprocal. Now that I have this written, let's go ahead and write this in its factored form. Let's try to factor all the numerators and denominators and see if we have anything that we can cancel out here with that. So here I have this 2 minus x. We're actually going to end up doing something with that here in a moment, but I'll save that for a little bit later until we can see why we need to do that. This trinomial here, x squared plus 2x plus 1, will factor as x plus 1 times x plus 1. Over here, this on top is a difference of squares, so it'll factor as x plus 1 times x minus 1. On the bottom, x squared plus 3x minus 10 will factor as x plus 5 times x minus 2, like that. I have to close my parenthesis there. Now that this is being multiplied, throw parentheses around that as well. Now that this is being multiplied, I can just smash this all together as one fraction, and then look for things in the numerator that I can cancel with things in the denominator. The first thing I notice is this x plus 1 right here and this x plus 1 right here. So this factor of x plus 1 can cancel one of these factors of x plus 1 from the denominator. I don't see anything else that matches up exactly, but I can actually do a bit more to simplify. You notice this 2 minus x over here looks a little weird. So I'm going to rewrite that. First I'm going to reorder the terms. Instead of 2 minus x, I'm going to write it as negative x plus 2. I didn't change anything other than the way it looked. I just reordered the two terms within there. The x is still negative, the 2 is still positive. And now I'm going to factor out a negative 1 from that factor right there. When I do that, that will change the sign of everything inside. So that will become a positive x, and that will become a negative 2. By manipulating the way that factor looks a little bit, now I've created another factor that's the same in the numerator and denominator, and I can cancel it. So this x minus 2 and this x minus 2 can cancel. Again, don't forget about this negative sign that didn't get canceled that you factored out. That negative 1 that you factored out is still part of your answer. So simplifying this a little bit, I'm running out of room, but I'll try to fit this in over here. On the top, I have the negative that I factored out, and then this x minus 1. And in the denominator, I have a factor of x plus 1, and I have a factor of x plus 5. So this right here is my simplified form of this original division of two rational expressions. Now, what we didn't talk about yet are the restrictions on the variables. That's another spot that often gets a little tricky for students in this particular problem. We're going to look at what values would have made the denominator of the first fraction equal to 0. I can see that when it was factored right here, I had two factors of x plus 1 in the denominator, so I would have negative 1 as a restriction. If x was negative 1, that would make this fraction be 0 in the denominator, which would then be undefined. So for my restrictions, I have x cannot equal. I know it can't equal negative 1. Now, here's where usually students might want to make a mistake with this. This second fraction, we actually have to find the values that make both its numerator and its denominator equal to 0. Because this x squared minus 1 was in the denominator right now, so whatever values would make it undefined would make this original expression here undefined. Sorry, whichever values made this equal to 0 here in the denominator would make this expression undefined. And then when I rewrote it as the reciprocal, this other expression became in the denominator. So I have to find the values that make it equal to 0 as well. So again, the restrictions come from the denominator of the first fraction and the numerator and denominator of the second fraction when it's a division problem. So I'm looking that I also would pick up, I already had the negative 1 from there, I'm also picking up a positive 1 here that x cannot be, I'm picking up a negative 5 from here that x cannot be, and I'm picking up a positive 2 from here that x cannot be. So I said, let's see, I said negative 1, I said positive 1, I said negative 5, and I said positive 2. Cleaning that up and writing those in order from least to greatest, it can't be negative 5, negative 1, 1, or 2 for my restrictions on the variables. And that pretty much sums that up. We've simplified the expression after doing the division, and we've stated our restrictions on the variables, remembering that those restrictions for these division problems come from values that make the denominator of the first fraction equal to 0, and any values that make the numerator or denominator of the second fraction equal to 0, because when that gets flipped, the numerator becomes the denominator, and the denominator becomes the numerator. Hopefully I didn't confuse you by talking in circles there. If you have questions, reach out.